we have Brian Turnbow that will tell us about the evolution of the access network in Italy.
Okay, I normally start my talks saying, how many people know TWT? But here a lot of people do, so I'll stop that. Just a brief overview that TWT is an Italian network operator. We do voice and data and cloud services, both directly to corporate customers and also as a white label service to, as we call resellers, which some of you know better than I do, I guess. But here I'm going to talk about the access network and how it works in TWT and what we've done and what we're doing actually as a project to evolve this network. Because if we take a look at the model of Bitstream in Italy, the model of Bitstream in Italy was born as an XDSL services. So we started selling Ethernet, ADSL, and Ethernet HDSL lines. And obviously they found out that, well, the technology has evolved, so now there's this great stuff called VDSL, or fiber to the cab, and fiber to the home. And so we want to start offering that. And so we said, great, we want to buy that. And they said, well, that's a whole nother service with a whole nother contract. And so you have to have two different services. And how do these services work? They really work the same way, where you have a DSLAM or an OLT in the case of the fiber optic lines, where each one is assigned a VLAN, and that's your service VLAN. That gets transported across the network directly to what they call the kit di consegna, or the switch where they terminate our services. Inside these service VLANs are your customers, and their customers can have their own VLAN in a double tag situation, or they can be all aggregated underneath the single service VLAN, as what they call the single tag service. And you know, this is pretty standard. This is the way pretty much everybody does it around the world. Where it gets a little more complicated is that they said, well, okay, yeah, it costs too much to have a kit dedicated for every service. Let's do these multi-service kits. And the multi-service kit, what's that? That's a switch where they terminate both services inside of it. But to do this, they create for you two different bandwidths, because you can't just have one service with one bandwidth. No, you have to have one bandwidth that they sell you for your XDSL services, and one bandwidth that they sell you for your fiber and GA services. And then they make it even more complicated, saying that, okay, well, inside that service kit, inside that service, we're going to make you pay your bandwidth for your cost zero bandwidth, your cost one bandwidth. So then what happens is that in every kit, you get a situation like this, where for every cost, for every group that you're selling, you have a single bandwidth to go, and you're going to be able to manage this single type of bandwidth. That gets kind of complicated once you bring this down onto the configuration level for the customers. And why is this? Well, because of your quality of service that you're going to be applicating. Because what you have to do is create an area level shaper for a group of VLANs. And okay, well, that's pretty easy to do in the Cisco world. You could use the service fragment, for example, and create this type of a group of VLANs inside of a parent level shaper. Well, we use PPPoA. And that makes things much more difficult. Because once you start axing and making your PPPoA group in terms of your, on your parent level shaper, you start getting errors saying you can't do that. So you cannot, on the ASR 1000 series, create a group of VLANs with a parent level shaper, and inside of that, create PPPoA customers where they have their parent class and child class. Why do we do this? Obviously, because we sell voice over IP services, and so we need to be able to create, via radius provision services, a customer that has a parent level shaper, so he has a 7 megabit, 20 megabit, 100 megabit line, whatever, where there's a parent level shaper, and inside that parent level shaper, we go and we create our classes so we can give him some priority bandwidth for his voice over IP services. Give him some guaranteed bandwidth, and things that we need to do to be able to sell the services to the customers. Well, not being able to do this with a single shaper at the group of VLAN level, what we had to do is make a decision. Okay, so what are we going to do here? Well, we're going to put something in front of our AS1000 where we have two choices. We can do VLAN aggregations and make all those VLANs turn into a single VLAN on the ASR 1000 series and handle all of the QoS on the ASR 1000 series. Or you can do your parent level shaping on the Metro Ethernet or ASR 920, and then do your subscriber shaping on the ASR. Both work fine, different philosophies, but you can do both of this, and that's a way that we've been doing it for a while. Well, what's happened? What's happened is everybody knows Moore's Law. How many people know Nielsen's Law? No? Nielsen's Law basically said that Nielsen's Law of Internet, and he started it way back in the 80s, was that a high-end user's bandwidth connection goes up by 50% every year. That's the line, and those blue dots are where we are practically. So it's pretty true, this law. You know, it kind of is gone with Moore's Law. And so what we see now is that we're offering services that are 200 megabits as a FTT cab line and 1 gigabit as a fiber to the home line. What's that mean? Well, that means if we take a look at what their bandwidth the consumers are actually using, these NGA fiber networks consume 3 times the mean bandwidth of an ADSL user. This is data that we got using the Association of Internet Provider, that most of the people that were involved in the project are here, so they know it well. And so what's that mean? Well, that means that we have to move to a 10 gig kit, you know, so we have to go with Telecom Italia, be able to acquire kits with a 10 gigabit interface and connect these to something because we need to terminate these customers. So we started looking around and we said, well, we have an ASR 1000, and the other option in Cisco land, here I'm doing some promotional work for you guys. In Cisco land, you have the ASR 1000 or you have the ASR 9000, basically. Well, the ASR 1000 was well known, it's what we had, but 10 gig ports are extremely expensive. They do have now a new IPA, the 10 per 10 gig port, which makes things better, but you need to use the MIP 100 for it, so that means we'd have to buy a new one anyways. And so it makes it hard, and you still need to use that fan-out device in front of it to do either loop your VLANs to consolidate them into one VLAN, or to do your parent-level shaping on a device in front of it. The other option, and a device with a 10 gig that does the VLAN mapping with an EVC or a parent-level shaper can be expensive too. The other option was to go with an ASR 9000. ASR 9000 obviously has a modern operating system, which is nice. It offers higher scaling. It gives bigger port densities, the per port costs that are more interesting, and you can also use satellites. So you can put a satellite in front of the ASR 9000 to get your port densities up really fast with a lower port cost. The other thing that we noticed is they have this thing that's great. It's called SPI, and basically it should allow us to aggregate our VLANs and create a group of VLANs. We haven't actually tested this yet, but this is on paper because we're actually in the work of doing this project. So hopefully we'll be able to not use a fan out, or if we do need to, with the satellite, the port densities are much higher, so it makes things a lot easier to do it. And all directly on the 9000. So obviously we decided to use a 9000. So once we started to say, okay, yeah, well, we like the 9K, let's do that. Well, what do? Well, you have 2 choices, really. You have a 9001 series, which is just a single processor. Most people probably know it. Or you can have a chassis level, so you have a modular device where you can decide which line cards, which processors, and whatnot to put in it. Taking a look at them, a 9001 would go up to 12 ports of 10 gigabits, so it's not a real high port density. You can use the satellites, which helps, so you can actually augment that port density. It's got Typhoon-based chips and network processing unit inside it, so we're going to talk about that a little more. And you've got 32,000 subscribers for a network processing unit. The 9001 has 2, so you could theoretically go up to 64,000 customers. And you do your redundancy with the new feature that's called geo-redundancy, so you could put a copy of these and have a almost no-hit type of down situation. The sessions would need to be reestablished if there was a switchover from one to the other, but we're talking about a pretty fast switchover. A chassis-based, obviously, gives you the same type of situation where you can use the Typhoon chip, or you can actually go with the new Tomahawk chips. And the Tomahawk MPU is a little bit more higher scale, and we'll see a little bit more about that later. And one thing that I don't really like about the 9001 is how many of you have done a recent iOS upgrade on one? It's not very fun. They don't have a very big flash, and the 2 gigabit file system limit is kind of hard when you're talking about iOS XR. Whereas the modular systems have the possibility, the new processors have a much higher flash, so it's much easier to handle images and upgrades and whatnot on them. Okay, when we start digging into it, this is where the things get really interesting, is Typhoon versus Tomahawk. Okay, here we've got some scale images on them, and the most important thing is, well, how many subscribers can we get on there? How many QoS policies can we put on there? That's the things that I was mostly interested for this project, because we're looking at access network. It's true, it's got a super processor on there, it's got more cores, it's faster, you know, and the thing. But if you take a look at it, there's also one big difference in the CPU. One is a 32-bit, if you look at the Typhoon, 30-bit Freescale PPC CPU. Whereas on the other side, you've got a 6-core Intel 64-bit CPU. Now this becomes interesting when you talk about iOS XR, because iOS XR right now is 32-bit or 64-bit. Talking to Cisco on this in the project, they said, well, so yeah, ISR 64-bit is the future. Right now in the access network in BNG, you should probably stay with 32-bit. So we said, okay, we'll stay with 32-bit, but we like 64-bit. So obviously it does a lot more stuff. But then when we talk about the subscribers, you had 32K for NPU on the Tomahawk, where you have 64 on the on the Typhoon, and on the Tomahawk we have 64K. So that's a double the capacity in terms of subscribers. Where it really changes, though, is when you start talking about chunks. Does anybody know about Typhoon and chunks when you talk about the quality of service? This is very interesting, because what happens in a Typhoon is a Typhoon creates 4 chunks. Okay? When we're talking about what I need to do here, I need to do subscribers, and each subscriber has to have a shaper on it, right? We saw that before. So each of my subscribers is one shaper, okay? Because each one has their own policy. Well, Typhoon takes those 32K subscribers and 32K shapers that it handles, and it divides it into 4 chunks. Each chunk can do 8K. So to do 32,000 users on a Tomahawk, on a Typhoon NPU, those users have to be on 4 sub-interfaces, okay? What does that mean? That means that I cannot have one area with one cost 0 for default internet traffic with more than 8,000 users. That's a big limit for me. May not be for you, but for me it is, okay? And so Tomahawk doesn't have this type of limit to it. So what did we do? We decided that we wanted to absolutely not use Typhoon and go to Tomahawk. And this is what we decided to do. We decided to go with the 9006 chassis, where we're going to use the redundant RSP with the 880. So we're going with the newest, best, latest, etc. We're also going to go with the Mod 200, and that gives me the Tomahawk, these two used together. And we're using fan outs with the NCS 5001 in front of it to get the added port density. And this was one of the key things that we did too. We found this, I don't know if any of you know Xander. Xander is the ASR 9000 guru inside Cisco. And this I found on a post, and I wrote the post on here, that he says, now one crux is that when we stated evolved XR, he's talking about using XR 64-bit for BNG. This means that you need a Tomahawk and RSP 880 chassis. This is not a sales truck, but evolved XR runs 64-bit and virtual machines. The Typhoon LC is based on PPC and 32-bit. So that means that you will never be able to run iOS XR 64-bit on Typhoon. And to get scale and the features that you need in an access network, we decided that that, for us, meant Tomahawk. And that was it. I was pretty good, huh? 10 minutes, boom, all right, we're liking that. Now, I don't want to stand between you and your coffee, but if there's any quick questions, I was that good at explaining it? All right. Good job.
Thanks very much, Brian. It was a pleasure.